So, inspired by this very silly game show, we are going to play today Name That Result. And the way that we're going to play Name That Result is that I've come up with a series of challenges that we have a series of challenges that can be answered using the OMOP Common Data Model and OHDSI tools. Each round, I'm going to pose a specific question, and the contestants are going to be able to auction for how long it takes them to answer the question using the OHDSI tools. So our contestants will be able to basically say, I can name that result in however many minutes. Whoever gets the lowest number of minutes that thinks that they can achieve the problem, they will be on the clock. I've got my clock right here that I'm going to show on my screen, and we're going to see whether or not the contestants can indeed answer the question and name that result in that time allowed. If they get it right, what will happen is whoever bids the lowest amount, they will show their screen, and we will all watch them as they attempt to answer the question in the time allotted. If they get it correct, then they will get 3 points, and I've got my own little leaderboard on my screen to keep track of things. But those other contestants who are not sharing their screen, they can also try to figure this out themselves. And if the person who gets the, if their time runs out, then somebody can have the opportunity to share their answer and they can steal for a point. And whoever has the most points at the end of this hour wins. Okay, so that's the game. Martin's already questioning his life choice of signing up here. I'm super excited that we actually had 8 folks that volunteered to participate. And so I actually first want to take an opportunity to allow our contestants to introduce themselves, share their name, where they're from, and one fun fact about themselves. Kristen, I'll start with you.
I'm Kristen Koska. I'm from Northeastern University. And fun fact, I am my own twin study. I'm an identical twin.
Very good. Philip.
Hi, can you hear me? Yeah.
Yep.
I'm Philip Maljkovic from Serbia. I work in Heliant, and a fun fact about me is that I can speak about 6 languages, but truth be told, 4 of them are Balkan languages, so it's a cheat.
Very good. Thank you, Philip. Welcome. Martin.
Hi, everyone. I'm Martin LaValle. I'm a PhD student biostat at VCU and also now part of the Odysseus data science team. Fun fact about me. I don't know. I have something fun happening to me besides this game, getting a puppy today. So this is just a fun day for me.
That is awesome. Very good. Catherine.
Hey everybody, I'm Catherine Simon. I work with Vanderbilt and the VA. Fun fact about me is I am a certified diver.
Awesome. Welcome, Catherine. Maxime.
Maxime from the Netherlands, currently in a small town called Berchem. A fun fact, although I'm from the Netherlands, I like mountain sports, bit of climbing, bit of mountain biking, but I have to travel quite far for that.
Very good. Welcome, Maxim. Stephanie.
Hi, this is Stephanie. Can you hear me okay?
Yep, we can hear you.
All right. So I work at Johns Hopkins University. Fun fact about me is I have twin daughters.
Awesome. Very good. Michael.
Hey, this is Michael Cook. I'm also from Johns Hopkins University, and a lot of twins today because my fun fact is that I'm also a twin, however, not identical.
Very good. And Jose.
Yes, my name is Jose Posada. I'm from Colombia, from Universidad del Norte, and a collaborator from Stanford. And fun fact, I play the trumpet.
Awesome. Very good. Well, first, I just want to thank all 8 of our contestants for signing up, sight unseen, other than me just saying, please sign up. It's pretty cool that we've got a couple Titans. We've got folks representing the US, Europe, and the LATAM regions. We've got newcomers and old hats here, so it's going to be a very fun game. So let's get started. I'm going to demonstrate this as how we could possibly play it with a very simple question. if the challenge to you all was how many patients are in a database, then your task would be to provide a solution to that problem. So you, all 8 of you as contestants, you guys can probably just unmute yourself as we play throughout this game. But basically, this would be an opportunity for you to say how many minutes it would take you to name that result. You gotta be unmuted, Kristen.
Less than 1.
All right. So you say I can name that result in 1 minute. So you would win the opportunity to play this game. In which case, then you would share your screen and show any solution that you can come up with to solve it. I will be keeping a little timer here. So basically, I would be starting my timer, and we'd all be watching to see if you could actually get your answer in under 1 minute. Solutions that would be acceptable to this problem would be something like an SQL-based solution. So you could just say, well, the answer is select count star from person. Or you could pull up on your screen Achilles and show where you could navigate to the number of persons in an Achilles view. Or if you guys are using Aries, you could go to the corresponding place in the Aries interface. Or in Atlas, you could actually go to the data sources tab and look up the number. Or you could, in fact, even construct a cohort and generate it and observe that the number of persons would be observed in Atlas. So whatever is your tool du jour for your particular question, you would have 1 minute to have answered it. And I just showed you 5 answers in less than 1 minute to this simple question. Okay. Contestants, are you all clear about this game that we're about to play?
Ready to go.
Okay, so
Ready.
I'd suggest that you all get off of mute because you're going to want to have the opportunity to scream out how many minutes it's going to take you. And whoever nails the lowest number is going to be the first on the docket. All right. Your question is, how many patients are female?
1 minute.
1 minute.
Jose can name that result in 1 minute. All right, Jose, share your screen, please. And as soon as you share your screen, I'm starting the clock. All right, go.
Done.
All right, done. All right, so I'm going to pause it. You've got your 3 points, but take a second to explain to everybody what they're actually looking at and how you got there.
So this is Stanford instance of Atlas, and I got into data sources, and there is a dashboard that provides a nice summary of the database. And one of the first summary it provides is a breakdown by gender. So that's how we got here, selecting the database, select dashboard, and we get a breakdown by gender. And here are the females.
Very good. Well done, Jose. 3 points for you. I'm going to go back to share my screen. Right, the screen sharing is going to be a little bit annoying, so you're going to forgive me for that. I'll just show for those that are particularly interested. If you were interested in those of you who are not using the Atlas tool but are interested, if you wanted to know how you could just like write a simple query for that, if you knew that the concept ID for gender was 8532, maybe because you were previously one of the lucky ones to be a part of the Women of Odyssey and know that, you could just write a query that would say select count star from person where gender concept ID is 8532. Or maybe you don't actually know that number off the top of your head, in which case you could write a query that says select count star from person where gender concept ID is in select concept from concept where concept name is female. And that will be the inner query that would have found you the concept ID 8532. Or if you really didn't know, you could actually just count up by gender and then look at the concept ID and see what comes back. But lots and lots of ways to solve that simple problem. Well done, Jose. All right. So if that was so easy, then I'm sure I'm going to be eager to hear who's going to ask to answer to name that result with the following question. What percentage of patients have at least 3 years of continuous observation?
Five minutes.
Jose can name that result in 5 minutes.
I'll go for 4.
Maxim says 4.
I'll say 3.
Michael can name that result in 3 minutes. All right, Michael.
2.
Oh, Kristen goes
I'll
for
do
2.
it.
She can name that result in 2 minutes. Okay. All right, Kristen, it sounds like you get to name that result. All right, Kristen, share your screen.
Just like the level of anxiety of just trying to do this right now. It's like a buzzer beater. Okay, is my screen shared?
It is shared, and I'm starting the clock now.
So if I had a tool like Atlas, I could go to observation period and data sources, and I could see that in my cohort, I have 3 years of observation time for 40 people. Does that count?
So the question was, what percentage of patients have at least 3 years of continuous observation?
Guess I have to do 40 out of my total. 100. How many people am I? 1,000. So 40 out of 1,000. Anyone want to help me? Actually.
No, you bid against me. You're on your own.
I love the smack talk.
So your
It's
tooltip
4
doesn't tell you,
4%.
but it's 4%.
All
If we
right.
interpret our, I don't know if my labels are right, so I will claim ignorance. I'm using the dashboard, but.
So if you scroll down a little bit, Kristen, look at that graph underneath there, cumulative observation.
Yes. I could have also just not used my phone calculator, but would you know, same percent.
There it is, 4%. Well done, Kristen. You named that result in 1 minute and 12 seconds. Good job.
So Kristen, can you quickly show how you got there? That's a really interesting tool, and I think kind of the point of why we're doing this little exercise.
Indeed.
I will. So if you're in data sources, which is the artist formerly known as Achilles, you have the option, once you select your data source, to select a report, and towards the very bottom is observation period. And then this just has a bunch of renderings of observation length. So it's like about halfway down.
That is awesome. And can you show that list of reports again? That looks like a lot of very interesting reporting that you can get for free when your data is in OMOP.
Yeah, Achilles is fantastic. We can put the link to the GitHub repo to the how this code is generated. And I know Ajit and other folks are on. This is an oldie but a goodie. It goes by many names.
All right, getting Atlas plugged into my system has just become a new priority. Thank you.
Very good. Very good. And yes, thank you, John, for chiming up. If others have questions and comments, obviously we're just having a little bit of fun and games here, but the whole point of this is some of you are probably going to learn a couple things here, and this is just kind of a nice, fun way to do it. Or at least I think it's a fun way, but I've got a distorted sense of fun seeing the panic in the contestants' eyes. If you were interested in just understanding, like, how could we actually figure that out? Very, very clearly, we are using the observation period table. So we could count the number of people who are in the observation period, who have a difference in their observation start to observation end that exceeds 365 days times 3. And we can just divide that number of persons by the number of persons in the database, and that would give you a percentage. If Kristen were to have run the same exact SQL query, she would have gotten the same answer that she was able to just click through and show in the Atlas Data Sources tab. All right. Well done, Kristen. We've got 2 on the board with 3 points. And a third question coming up here is, how many patients are females with an observation period of at least 3 years of continuous observation? Let the auction begin.
Well, I guess I'll say 10 minutes.
All right, Michael.
Definitely get into that time.
Name that result in 10 minutes.
5.
Philip can name that result in 5 minutes. Catherine just went on mute, so I'm gonna think that Philip, you got 5 minutes to solve this problem. Hearing nobody else, share your screen, please.
Oh, geez, I shouldn't have done that.
The stakes are extraordinarily high here.
You just said the quiet thing out loud. We were all thinking.
Can you see my screen?
See your screen and your clock starts now.
Yeah, so I'm having trouble with date diff in Postgres because I was trying to construct this in the first in the previous task, but I thought I could Google stuff and find ways because I'm not native to Postgres, but because this doesn't really work, and what you showed, Patrick, didn't really work either. Like DD for some reason doesn't work. So if anyone wants to help, that's fine.
Is he allowed to phone a friend?
Yes, if anybody wants to offer help to Philip as he's going, feel
I think
free
in
to.
Postgres you can just subtract them.
Really?
So I might be a liar. I'm saying it out loud, and there's lots of people here.
But what do you get when you do that?
You'll get days.
Are you sure?
No.
You want to do the subtraction and then say where greater than interval 3 years. The result of the subtraction is an interval.
Ah, but like I'm just trying to subtract them and it doesn't really work, right?
I'll look it up.
Just do the subtraction in your select. You'll see how it comes out.
Well, that's what I did, but it doesn't.
Erica, that error query we used earlier this week has it in there.
Well, then tell him.
Yeah,
Oh, is it
it's what Edward's saying. It's interval.
Leave
yeah.
SQL behind. Try Atlas. You have so much time.
Like interval. Like so?
No.
No.
It's where the end minus the start is greater than interval 3 years.
Ah.
And I think it's just interval space and then 3 years in quotes. No parens, just a space.
Ah.
It's not a function, yeah.
Like this?
Yeah, I think so.
Oh.
This comment is not allowed. That's been your problem the whole time, I think.
Oh, I'm still not subtracting them. Okay. That's fine. What about now?
Oh, because you're trying to solve something in the select statement. So get rid of the interval part for now.
Ha.
Oh my God, Postgres.
Delicious.
No, I might have lied. I think the date diff does work.
Really?
So hold on, Postgres. Where's Chris Knoll?
Yeah, if you just write out the word day, so do date diff and just write out day instead of DD. They get funky. Try that.
Sorry, I think I tried that, but it didn't work.
You would need the subtraction sign when you do day. Between end date and start date.
But this is
You
a
also
function
don't have
call.
a complete where clause now. You just have where date diff, but you don't have a condition.
Right, let's try this.
Yeah,
No
so
function matches the given name. Ha.
replace the comma between end date and start date with a subtraction and with the day and the date diff.
Oh.
And I don't think you put quotes around day.
Yeah, you don't.
You don't. I'm just trying things.
We're close.
But day doesn't exist.
Huh. Hey, Postgres.
Why are you doing
Why
this?
can't I wait? Get rid of the subtraction in there.
Okay. I'm getting mixed signals.
Run that again.
I swear to God, this is Postgres.
Pissed, I think. Date diff.
I did this.
Don't you have to do the date diff and then do a date part to get the days out of it?
So, according to Martijn's SQL render, it's just indeed subtracting, and then you get the number of days.
In your last 20 seconds, if you go in the chat and click on the cohort link, you can get the answer not using SQL.
Oh. What? Oh, right. Like this.
All right, your time is up, Philip.
Oh,
so
All right,
close.
but this is a good learning experience, and I see Catherine has raised her hand for the steal of the 1 point. So Catherine, share your screen.
All right.
Oh yeah, I forgot we could do that.
All right, Catherine, can you walk us through your code there?
Yep, I'm using person table. I've got it filtered for females, inner joining onto observation period, and where the date diff between the period start date and end date is 365 days times 3.
Awesome. Well done, Catherine. You earned a point for the steal, and that is a very nice example of SQL. I'm going to take chair prerogative to offer Kristen the chance for a second steal point. If you would share your screen, Kristen, and walk through how you solved it.
Sure. Yeah, so I hate SQL. There's nothing wrong with you if you hate SQL too. I rely on my friend Atlas to create a cohort, and you could create an entry event that is an observation period. You said 3 years, so I had to look up. It's 1095 days, so greater than or equal, and then you can add an attribute from demographics to pull that female 8532, and you can execute that cohort against what you have. So I have 2 cohorts in SynPuff, and I believe by the letter of the law, that counts. And I could look at the text if we wanted to. Not that I love looking at machine generated SQL, but we can use this to figure out your homework. There's CTEs in here though, so it's a little bit harder to read this. But that's how I would do this, because I personally find SQL torturous.
That was well done, Kristen. You have earned a point. So the leaderboard now is that Kristen is leading with 4 points. Jose has 3 points, and Catherine has 1 point. And Philip, you get a gold star from my heart. All right. Next question. Let me share my screen. All right. Oops. Can you guys see my screen? I lost you guys. There we go.
Not
Okay.
yet.
All right.
Oh, there it is.
All right. The next question for the auctioning is, what is, oh no, I didn't want that one, sorry. What is the standard concept for dexamethasone?
1 minute.
What's that, Maxim?
Less than 1 minute.
Wait, who said it first? I lost it. Craig, you need to be my arbitrator.
I think that was Maxim.
Maxim, you got in there. Less than 1 minute. Okay. So Maxim, if you can share your screen.
Are we allowed to use Athena?
You are allowed to use whatever tool you want.
Well, let's keep it with Achilles then. All right. Can you see my screen?
We can.
So let's search the concept and hope I spelled it correctly.
And also hope that Atlas loads in time.
Otherwise, let's already fire up. Ah, there we are. Ooh, and then the standard concept. So let's filter on that. And there we are. I would say it's concept ID 151822524.
Very good. Well done, Maxim. So that was very nicely done. So you used Atlas to search the vocabulary to identify the standard concept. So that was a good solution. Does anybody want to offer up an alternative approach to that?
I did Athena.
You did Athena?
Athena.
If you share your screen, you can have a point to share for there.
Ha! Let's do that. So do you see it?
It's green. Now we see it. Yep.
Yes. So I searched for dexamethasone in the domain drug and concept standard, and it was basically the first one. But I could probably lower it down or use ArcSnorm and maybe some other filters.
Very good.
Yeah, like the ingredient get to narrow it down really to this.
Awesome. Well done, Philip. You get a point. So we've got lots of different ways we could find the standard concept for dexamethasone, which is very helpful. Your next question, contestants, is, once you see my screen, for you to auction on is, how many descendants concepts does dexamethasone have?
1 minute. 1 minute.
Jose says, gets in there with a minute. All right, Jose, share your screen.
Same Athena drug under this one, dexamethasone. And once you click there and this loads, oh, loading time. It's playing against me. No. Please load. Okay. Okay, it loaded. So then you can see here how many descendants it has because give you all
You gotta
this.
count them, Jose. How many are there?
No, there is a count here.
1,
It used to be a
2,
count
3.
here. No, I lost. Used to be a count here. No, okay, I lost.
You still have 10 seconds.
Oh no. Okay, I have another way to do it, but I will need 1 minute more now. But there used to be a count there, and I forgot that it's not anymore. Oh, sorry. In the hierarchy, maybe.
Question didn't say it had to be a
No.
quantitative answer. You
Time.
can say a lot.
Yeah.
Time has elapsed. I see that Maxim, you were the first to raise your hand. So I'll give you a chance to share your screen and show your approach to this.
I used the community, and apparently Link Xiao says 1343.
Using
Let
the
me see if I
community,
can
that's
prove
well
that.
done. I'll allow it, but would you like to show another approach also?
Yeah, so I used SQL here to count the number of how many concepts have as ancestor concept ID this concept ID of dexamethasone. And actually, for me, it's 9,652. So it's actually quite a lot more.
Very good. Could you just make that your screen just, or could you like make your text just a little bit bigger so people could see the query you wrote, Maxim?
Let me try.
Is there a depth field on that table? Can you get the primary descendants versus, descendants that are further down the tree?
Yeah, so it's a good question, John. So the concept ancestor table only contains standard concepts, but it contains the degrees of separation between the concept that you're choosing as the ancestor and how many basically hops down you have to go to get to the descendant. So if you want all descendants, which was the question here, what Maxim done here is totally right. In that you just can basically, if you knew the concept ID for the ancestor, you pull them all in. If you wanted specifically those things that are just one straight hop away, you could just set the min levels of separation, or you could say where min levels of separation equals 1, and then that would get you the 1 hop away descendants.
Beautiful.
Okay. So Maxim, you get a point for the steal there, but I see that Michael, you've also raised your hand. So do you have a different approach you'd like to share?
Sure. I'll go ahead and share my screen. So I will be attempting to use Atlas. However, I did not write down the correct spelling of this. What was it? Dexamethasone?
Yes, DA, yep. Meth, yeah, zone.
Like
Yep,
that?
you got it. Well done.
Except I mean, there's only supposed to be one M. So I'm going to go ahead and search this in Atlas and hope that the search returns results quickly. Within the allotted time of 1 minute. I don't know if there's still the minute time for steals or not. Or if this is a bonus steal, I don't really know.
It's very strict rules here, Michael.
Yeah.
I'm running
right.
a tight ship when it comes to the silly Odyssey name that result game.
All right, so I hit standard. It looks like our first one here, dexamethasone, has 948,773 descendants. descendant
Ah,
risk.
so this is a good one to point out, Michael. So that's the record count in the database.
Oh no, you're right.
That's how
No.
many people are in the data set that you're looking at.
I got too excited.
You're almost there though.
I forget if it's under related concepts or hierarchy.
Yeah, related concepts is the place where you want to be.
Very good.
I'll let you show it.
This is the problem with a large data source in Atlas. It takes a while to load up everything. I think it's Kristen that has like the 1,000 cohort or 1,000 patient data source in Atlas. That's the cheat code for this.
Actually, notice that related concepts tab's always really slow. Also,
Is
in
it really always
smaller
slow?
data. Yeah, hierarchy is much faster, but I wouldn't advise you to go there now because then you lose your
Yeah.
computing time. But if anyone has any tips on how to speed up these related concepts, very welcome.
See if
There
I
you
do.
go.
I
There's your
believe
number.
has descendant of should get me to the right number, 9634.
You did it. Well done, Michael. Well done. You got a point there. Good steal. And Martin, I see you raised your hand. Do you have another way to show how we could have gotten this answer?
Yeah, let me try to share my screen. All right, so can people see my screen? All right, so I use some code that I took from an OMOP vocabulary training and used that. And then I had a custom query extractor for rote and R and then get the number of rows. So 9,464, which I checked with the previous solution. So this is the same.
Awesome. Can you just take a second to walk through that code, Martin? This is really great.
Yeah. So this is the custom SQL code. So this is the number of separations from this concept ancestor and concept. So we're looking at the concept ancestor, which is dexamethasone, and then with the descendant IDs matching this concept ID from here. And then we want to order that from the number of separations. So if we do this and then we create the table, so then I can look at, oops, that's not the right one. I want that one. So this one's going to create a table. And so this is going to look, so we have max number of separations. So the top one is going to be dexamethasone. So that's the ingredient class, and everything else with a different level of separation. So whether it's an ARCS norm extension, so like a brand name or something like that, will be like one away from that. And then there's like a list of all sorts of other ones.
Awesome. Well done, Martin. And nice to see a little R code dropped in here for good measure. So just doing a quick recap. Our two Titans, Kristen and Maxim, are at the top of our leaderboard with 4 points. Jose has 3 points. Catherine, Michael, Martin, and Philip each have 1. All right.
All right, come on, Stephanie. Let's represent Hopkins.
Here we go. I'm going to share my screen. Next question. Rivalries brewing. All right. Can you guys see my screen? Next question is, oops. How many patients were exposed to dexamethasone and its descendants?
3 minutes.
Jose
2
says
minutes.
3 minutes. Kristen says 2 minutes.
Oh, God. Oh, yes, I can do it in 1 because I already wrote the code.
Jose says 1 minute. All right, Jose, share your screen.
Oh, God. Screen sharing. Okay.
Jose, you have to do it in English. No, I'm kidding.
Jose, clock starts.
No.
And Michael's got his hand looking for a steal.
What was the question? How many patients or how many exposures?
How many patients were exposed to dexamethasone and its descendants?
Okay.
Oh, time's up, Jose. Time's up.
Oh, I wrote the query. I wrote the query.
Oh, let's see
I
it.
wrote the query.
All right. Can you make it a little bit bigger? On my screen, it's very small. All right. Count distinct persons from the drug exposure table where the drug concept ID is in all of the descendants of the ancestor. Jose, 3 points. Well done. Well done. Good job. That is stressful programming, but you nailed it. Even though you got the right answer, I still see a bunch of hands get up, so I'm going to look for other solutions. So Michael, you can get a point for an alternative solution here.
Sure. Unless I'm mistaken, this is what I mistakenly did earlier. Dexamethasone and Atlas. I believe the descendant row count should just be that answer. So I'll just search that again and just show that again. I pressed search already before I shared my screen, and yet
Who wants to tell him? Who wants to tell him?
Ajit raised his hand. I think he wants to tell him.
Yeah, I was trying to raise my hand, and I don't know if I actually raised it or not. Yeah, that's going to be the descendant record count. What we're looking for is descendant person count. And so if you have Atlas 2.11, you actually do get 2 more columns here for person count and descendant person count. So that would be
so we need to upgrade.
Very good.
All right.
All right,
so
but Michael, for that effort, I'm giving you a quarter point.
Thank you. Thank you. Looks like we need to get an upgrade.
Maxim, did you have a solution you want to share?
Yeah, a variation of what Michael did, because I thought the same, like, can we use Atlas? So I was thinking, let's look at the drug era report of the Achilles, the data sources, and then look at all the person count of the ingredient dexamethasone. Maybe not technically all descendants,
No,
but I guess it's close.
That's a totally valid approach, because our logic for the drug era is that we do ingredients plus descendants to roll things up, so that count would totally be legit. Well done, Maxim. Point for you. And Kristen, you're going to get 1 chance here too.
Absolutely. Why didn't you just build a cohort definition, guys? Oh my gosh. So I made a cohort where the drug exposure is dexamethasone. It's a concept set that pulls the descendants. So new cohort, who dis? This is drug exposure dexamethasone. I executed it and got back to my counts on my 2 data sets.
Well
I don't think you
done.
had other restrictions, but if you did, I didn't read them.
Well done. Okay. All right, Catherine, you raised your hand, and Martin, let's see what you guys have real quick.
All right. All right, so I used SQL to create a concept ancestor table for concept ID 1518254. Enter joining onto the drug exposure table using the descendant concept ID equaling the drug concept ID, and got a count distinct of person IDs.
Well done, well done. Nicely done, Catherine. And Martin, you had a different approach?
Hold on, I need to share my screen. All right, so I did mine with Caper. So I'm gonna publicize my own package here. So similar to Kristen, I created a cohort here. So I created a dexamethasone cohort, then created a simple primary criteria since it's including all of the descendants, and then created a cohort and then used cohort generator from Anthony's package, and then get the count. So the dex cohort is cohort ID 1. So this is the number of subjects I have and the number of entries.
Awesome.
But
Well,
this is admittedly slower than everyone else. So
no, but that's well done, and actually showcasing the CAPR package is a good thing, just to show there's lots of ways to solve these different problems. So we have 4 minutes left. We're going to have 1 question. Leaderboard right now, Kristen's got 5, Maxim's got 5, Jose's got 6, Michael's got 1.25. Catherine's got 2. Martin's got 1. Martin's got 2. Philip's got 1. So you know what? The final question is a 7-pointer for all the marbles. Here we go. How many patients were new users of dexamethasone in descendants with a prior 365 days observation before first exposure? Oh, Kristen goes for 1 minute. All right, Kristen, share your screen. In 1 minute, we're going to create a new user cohort of dexamethasone with a prior year of observation.
I'm going to regret this, but why not?
You can do it.
All right. How many? Do you tell me when am I starting?
Sure. Share your screen, please.
Okay. Can you see me? All right.
Right. Go.
Said new users. And what was either prior 365?
Yep.
And any other logic that I've not heard?
Oh, wow, the double generation. That's risky.
That's right. I got one back. So 50% success, 100% success. I think this was what you asked for, but I actually don't. I can't see your cohort definition, so I can't.
Yep. That is it. You nailed it. You nailed it, Kristen. So we asked for new users of dexamethasone plus descendant with a 365-day washout period, and you were able to name that result in under 1 minute. G, do you have your hand up for a reason, or is that still from last time?
It's from last time. Team.
Oh, he's gonna steal. G for the steal.
Very good. All right.
Steal the winning points.
Kristen, you won. Name that result 2022. Congratulations. Well done.
Wait, we're not doing this again for a whole year?
Oh no, we're gonna do this again for sure.
So thank you. I want to thank Kristen, Philip, Martin, Stephanie, Michael, Maxim, Catherine, Jose for playing this silly game. As John immediately jumped in, and I want to just reinforce the point of just kind of doing this silly little game together is recognize we can do a lot of super powerful things across our data network using a lot of different tools within our community. There is no necessary one right or wrong way to do things. There's lots of different flavors of doing things. But if you think about what we just did over 45 minutes, we just actually solved 6 totally legitimate questions, each of them actually being answered in under 5 minutes, and most of them being answered in under 1 minute. And you saw many different tacks and approaches. Now, we just did this in kind of a flurry of events over 45 minutes, but imagine if we actually treated the real research questions that we actually cared about together, and we were to get together with Martin and Michael and Kristen and Catherine and Philip, and we all were to sit down together and say, okay, what is the clinical question we actually want to answer, and what is the way we can tackle this problem using the OMOP Common Data Model, using code, using the OHDSI toolkit. It's amazing what we can actually accomplish in a short amount of time. Time shouldn't be anything that we use as an excuse for not having high quality, but the reason we have standardized tools is actually ensure that the tools do exactly what we need as long as we actually train ourselves up in understanding them. So I want to thank our contestants. Big round of applause for everybody for participating. Kristen, you win the entire parting prize, which is nothing other than my
pride. I won my pride. Whew.
You have my respect. But I want to encourage everybody as you are coming on the journey of learning about all the OHDSI tools to reach out to your fellow collaborators and members and think about, if you're thinking that a question is hard, think about the fact that maybe it actually can be answered easily, even if it's a hard question. It just might be a matter of being creative about all the tools that we have available in our community. So thank you all very much for participating. Craig, I'll hand it back to you.
Yeah, not much to add. Thank you, everybody. Thank you, Patrick, for leading that, and everybody for joining. Reminder, next week, the OHDSI Coordinating Center. This is going to be an important call, so I do ask for people to join and see what DBMI and George and everybody there is doing to make sure that OHDSI can be successful. So join that. But thank you for joining. Hope you enjoyed. Hope you had learned a little. Have a good day. Have a good week. We'll see you on Tuesday.